So for this one is 7.5 and 7.6. I can find missing sides of similar triangles. Two figures are similar if all their corresponding angle measures are congruent, so the angles have to be exactly the same, and if their corresponding side lengths are proportional. If two angle measures in one triangle are congruent to two angle measures in another triangle, then the triangles are similar. So in triangles, we have a special rule where if three angles are congruent, then they're similar. But since triangles add up to 180, if two of the angles are the same, then I know that the third angle has to also be the same. So I really only have to check two for triangles. So for my first one, I'm going to determine whether these two triangles are similar. If so, we're going to write a similarity statement. So it is a little bit hard to read. I know this one is 62 degrees. This one is 48 degrees. This one's 62 degrees, and this one's 70 degrees. So I have to figure out what these are. I don't have enough information. So I know triangles add up to 180. So 180 minus 62 minus 70 will give me that missing angle. 180 minus 62 minus 70 is 48 degrees. So this angle is 48 degrees, which means we have two sets of congruent angles, because these are both 48 degrees, and these are both 62 degrees, and this one would have to also be 70, that means. So these two triangles are similar. When we write our similarity statements, if I say triangle EFG, I write is similar to, so the squiggle means similar, triangle F matches with B, because those are both 48 degrees. And then I said, F does match with B, but E should be first. E was 62, so I have to have A first. That's also 62 degrees. F was 48, so I have to have B next. G was 70, and I had G third, so C has to be third. So I'd say triangle EFG is similar to triangle ABC. Okay, then for the next one, I know these two angles are both 110. I don't know what those angles are, but they're vertical, so then they're going to be congruent. So since I have two sets of congruent angles, I know these two triangles will be similar. So I can say triangle JHK is similar to triangle M would correspond with J, H corresponds with L because they're both 110 degrees, and I would say angle K. These two correspond because they're vertical angles, so they're congruent. Okay, we can also use this special method of indirect measuring to figure out missing lengths of things that we couldn't actually measure. So say this lamp post is too tall for us to measure. We want to find the height of it. It casts a 26-foot long shadow. The fire hydrant's only 2.5 feet tall, so it's easy to measure, and it casts a 5-foot long shadow. That makes two similar triangles, so I can use proportions to solve for the missing height, or the height of the lamppost. I always do big over small, so I would do h over 2.5 equals 26 over 5. So I have 5 times h equals 26 times 2.5, which is 65. And then I divide by 5 to get h by itself. So I get h is equal to 13. So the height of the lamppost is 13 feet. I'm just going to do one more of these. So we're going to do example 2 up here. It says triangle DBA is similar to triangle ECA. Ramon wants to know the distance across the lake. So it didn't print. There's a lake right here. It's really hard to measure across the lake because we'd have to either boat out or swim out to measure the distance across. But if I know this is all on land, all these other measurements, I could use similar triangles to find the length of D. So I'm going to put D on top because it's on the big triangle. It corresponds with 40 on the little triangle. So the big triangle is this. The little triangle is this small one here. And then the hypotenuse of the big triangle is going to be 320 plus 162. So that would be 482 over the hypotenuse of the little triangle is 320. So I had to add these two to find the hypotenuse of the big triangle, this number up here. So I would do 40 times 482, which is 19,280 equals 320 times d. Divide by 320. Sorry, you can't see my equation. So I get d is equal to 19,280 divided by 320, which is 60.25 meters. So the distance across the lake is 60.25 meters. I'm going to have you do example 3 for your question and submit that in the answer box. So it says, how far is the water ride from the roller coaster? That's this distance over here, round to the nearest tenth. Okay, this next part is different. So you're submitting example 3 for this one to get credit for this video. This one says triangle RST and gives the vertices -4, so 1, 2, 3, 4, 1, 2, 3, 4, 5. S is -4, +4. T is 2, -4. 1, 2, 3, 4. That doesn't look right. Oh, this was -4, -4, sorry. So S is actually down here. That makes a lot more sense. There's triangle RST. And then we also have triangle UVW. So U is at -2, +2. So there's U. V is at -2, -1. And W is at 0, -1. So right there. So the directions, at the top say graph each pair of similar triangles. Then write a proportion comparing the rise to the run for each of the similar slope triangles, then find the numerical value. So our proportion this time is going to have letters in it instead of numbers. So we're going to do rise over run. So rise, remember from doing slope, means this side. So side RS corresponds with side UV on the other triangle. Oops, there you can't see it. That should be equal to the ratio of the other two sides. So I'm sorry, I messed up. Rise over run of the same triangle. So it's rise over run, just like when we found slope, ST. That should be equal to the same thing from the small triangle. So the rise is UV over the run, VW. That says UV and the run is VW. So those two proportions should be equal because these are similar triangles. Rise over run equals rise over run. The numerical value should give us the slope of the hypotenuses. And the hypotenuses are on the same line, so they should have the same slope. So for this one, the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6, 7. Did I count that right? 1, 2, 3, 6. 9 over 6, sorry. And it should be a -9 since it's going down. We do the same thing with the orangish triangle. It goes down 1, 2, 3 over 2. Are these two ratios equal? They are. And this one's more simplified, so this is the slope of the hypotenuses. So what this one is asking us for is we need to have the proportion comparing the rise over the run. That should be done in letters. And then that simplified should give us the slope. So the slope of the hypotenuse will be the same for both triangles because they're similar. And it's the same as doing rise over run. We're finding the slope of this line. Okay, we'll do the last one, and I'll try not to mess up so it's a little bit more clear. So we have triangle CDE. C is at -6, -3. 1, 2, 3, 4, 5, 6, 1, 2, 3. So there's C. D is 1, 2, 3, 1, 2. D. E is -3, -3. So there's triangle CDE. Triangle MNQ is at 0, -1. There's M. N is at 6, +1. 1, 2, 3, 4, 5, 6. There's N. Q is at 6, -1. Okay. We need to compare the rise over the run for both triangles. It doesn't matter which one I do first. I'm going to do the green one first. The rise is 1. The run is 3. The rise for this one is 2. The run is 6. Are those equivalent? They are. So 1/3 is the numerical value. That's the slope. I also need to write proportions using the names of the side lengths. So my rise here is ED. My run is CE. My rise on the orangish triangle or pinkish is QN. My run is MQ. q. So we need for this one a proportion, and we need to write the slope, or the numerical value.